Let's compute the integral of this function. I think it's very easy to get overwhelmed with something like this because there's just so much going on. You have this exponent in the denominator and it contains a trig function, and then you also have a trig function in the numerator. So where do you even start? So to avoid feeling overwhelmed with these kind of integrals, start by looking for a function and its derivative. In our case, we have the sine 5x and we have a cosine 5x. And the fact that these two trig functions contain the same angle means that I could do a quick substitution here. So if I define u as sine 5x, then I can find du as 5 cosine 5x dx. And I'm not worried about that factor, that constant 5, because I could just divide it. So I have du divided by 5 is equal to cosine 5x dx, and then that matches what I have in my original integral, which means I can rewrite this in terms of u. So to do that, I will take that factor of 1/5 outside of the integral, and then I have 1 over e to the u du, or 1 over 5 integral e to the negative u du. And now you could either just compute the integral of this right away, or if you don't know how to immediately take the integral of this, you can do a quick substitution again. And I'm just going to show it for the sake of demonstration. So I'm going to say a new variable for substitution, t, is going to be equal to negative u. And so dt is going to be negative 1 du, or negative dt is equal to du, and so my integral becomes 1/5 e to the t dt times the negative outside. And so my integral just becomes negative 1/5 e to the negative u, and then one more substitution, going back to my original variable where I defined u as sine 5x, I get that the integral is equal to negative 1/5 e to the negative sine 5x plus the arbitrary constant c, because this is an indefinite integral, and that's it.